Yes, I think we are live. Hey everyone, and welcome to the TestMU Conference 2026. Hope you're enjoying all the sessions and having a great learning experience so far. I am Shahzeb Huda, Associate Director Marketing at TestMU AI, and I will be your host for this session. Today, we are diving into a challenge everyone building with AI is wrestling with. How do you actually trust what your AI agents are doing? Wipes and looks good to me are not the deployment strategies, especially for agents with multi step reasoning and tool side effects. So the question is, how do you build evals that catch regressions before your users do and know when a human still has to be in the loop? And to answer that question directly, I am delighted to introduce our speaker for this session. Rushabh Mehta is a software engineer at Meta with 12 years of experience building AI and ML infrastructure at a billion user scale. He leads the development of environments for training and evaluating LLMs for agentic and tool use capabilities and has built a distributed training framework adopted by more than 80 models. Feel free to drop your questions in the chat as we go, and we will address them during the Q&A at the end. Also, post your takeaways on LinkedIn or X and do tag us using the hashtag TestMuConf so the rest of the community can follow the conversation. So please join me in welcoming Rushabh Mehta. Rushabh, over to you.
Hey folks, thanks for joining. I know this particular conference is virtual and there are so many people who are joining across all the time zones. So really appreciate good morning, good evening, depending on where you are. I'm super excited to be sharing my experience about how to build the trustworthy AI agents powered by Evals. Um, as we go along, I would ask like some questions. Feel free to respond through like interactive like emojis or something to just get a sense that we can make the most of the virtual setting what we have here. Thanks for Shazib for very warm intro. Just a little bit to add like my personal color. Been working at Meta for a little over 5.5 years now. Mostly I've focused on the ML infra and AI infra part of the broader set of things you can build in general. Most recently, how do you build agents in the correct way? What is the infra to support the ever increasing demands. When we talk about evals, many people simply write it off saying that hey, this is like just like some testing in a way, and like functional testing, unit testing. People have already used this mechanism to ensure quality. But then I'll add to what makes evals of like the AI in general like a lot more complicated, right? And I also got a chance to lead the post training platform within the company where the end users, which are again like within the company, but like they could bring their own data, and we would provide the capabilities for them to fine tune, post train on top of like the open source based models, and then deploy it like one click, and make sure like the new systems what they're building are built such that they can leverage the economies of scale. In the past, I've also contributed towards the natural language understanding component of Alexa. And going even further back, back in my master's days, I worked on deception detection. So on online reviews, can you figure out whether the review itself is fake or like the legit one? And if you, just like Steve Jobs said, like you can connect dots in backwards. These have enabled me to look at the same problems, same model releases in a like a very different lens. So perhaps like detecting deception in online reviews somehow makes you better at catching hallucinations from the AI model. So um, this is like the standard AI speak these days. Like X is all you need, like XYZ is all you need. Of course, it started from attention is all you need, like the famous paper which made the transformers uh, go very popular. But before I dive into like the parts there, I think it would be helpful to understand what is the audience mix here. I mean, perhaps like a quick show of hands, you can use the emoji if you've used any AI agent. So Claude, Codex, all these are like coding related agents. But on top of like the base, like the chat capabilities, raise your hand if you have used any AI agent. Cool. And then in terms of whether you have built an AI agent, that would mean that you took one of the base model, and then on top of that you built like your own agentic harness, and then provided like some tool use capabilities, purpose built for your own business use case. Awesome. Yeah, I think we have a good mix overall. Just to level set, right? I mean, um, when you say eval, like what do you really mean? You want to make sure like the new capabilities which you are going to enable by building the agent, uh, it is doing what it is supposed to, and at the same time it is also not doing what it is not supposed to. So many time you build any new product or feature, and you don't know how to measure the success. You don't know what good looks like. So evals basically can be that missing piece in the puzzle, which helps you define the success. So you can be like a software engineer or in a quality engineer, technical program manager, product manager, user designer, user experience designer. But you need like like a common source of truth. Like what does good look like? When do we know that what we build actually works? So eval helps in that sense. And as you go through that journey, you can also measure so many different aspects of it, both quantitative and qualitative. That's another reason why you should have evals. Catching regressions, I mean, like once you have already iterated, as you iterate after launching the initial version, you want to make sure you're not backtracking, you're not messing with what used to work before. So that again becomes very helpful. And not everyone has the not every environment would have the capability to spend enormous amount of money on like the proprietary models. Sometimes you want to make sure that, hey, you have like some proprietary set of data, and on top of open source models, can you combine that with the data, and like the fine-tuned checkpoint is what you end up using. And then while these are some stuff like you can sort of like think through, a very unique insight from my personal experience is that you would want some kind of flexibility in terms of where the model is actually deployed. So here in this particular example, like which cloud provider are you using, like what are the cost, what are the machines, like the actual GPUs they are going to be using. And if you are going deeper into this, you may want to experiment with like the different GPU types itself, and then perhaps run the inference by yourself. So with having an eval suite, it becomes very easy to quickly check the base capabilities you want to ensure, regardless of the cloud provider, regardless of the new NVIDIA or AMD GPUs. So from that perspective, evals are like won't call it a silver bullet, but like still gets you much further. So the next is when we say evals, let's look at like some layers into this, right? The underlying thing here is of course going to be the LLM itself, which is the next token predictor, and a very smart one at that, I would say. This is August 2026, but that by in itself is going to be good at like providing you responses again in like chat based or like like a string text format. But then for you to actually take actions, you need to couple that with the different tool use capabilities, and like bunch of different like search, browse across the internet, across your set of data. So that like the base model plus the tools can get you like what I call as like the agentic capabilities. And then given a particular agent, you want to when you want to evaluate, you would have a set of tasks, like, hey, here is a task that I want you to do XYZ. And whether the agent is able to do that or not, you can figure out by running deterministic tests. You can which would be like the code based graders. Otherwise you can run like the LLM-as-judge. So instead of deterministic piece of code itself validating, it is LLM which is validating the agent which you build. So that's where it becomes like a catch 22, right? And then there are human in the loop, where when you need like a lot more nuances to be handled correctly, you would rely on them. And then across this, of course, measure as much and as many things as you can, so that way you have an understanding of the cost, the tokens. The whole 2026 started with like token maxing as like a meme, but there is some truth to it, right? Like, I mean, by going big on token usage and actually experimenting as much as you can leverage this brief window in the history of AI, where the costs are subsidized to you as the user. And as you run all these things, that collective trace is called like trajectory, if I can say that. So the messages which from the user comes in, there, which is like the user prompt, as we say, right? There would be another thing called system prompt, that is model's internal message to itself. There would be reasoning traces, because as and when we expect more from the models, it won't be like, hey, just from rote learning from what you had already memorized, scraping the whole internet, like give me the answer. No, this would be something more real time, inference time scaling, as people say. So those all the details collectively, call it like a JSON format, like that is your trajectory. So that collectively becomes your like eval suite. And then once you run it against like all these tasks, some of them can fail, some of them can pass, and you can use the grader to evaluate, and that together gets you like the eval harness. So next can be like, what are the challenges in general, like with agents, right? Some of it is just stemming from the fact that these are based on top of the built on top of the LLMs. So like non-determinism, which is like inconsistent behavior across runs, just the model making things up, that's like your hallucinations. These are like, again, not new. These are just the quirks we understand, which seem to exist with the models itself. But then with agents, think of it as the model being the brain and the agent having the hands and like limbs. To actually perform actions, you need your hands and legs, right? So that is essentially like tool calls. Like you can have like your MCP servers, you can have like some API which the model will invoke. How do you make sure like those calls are going through as expected? So this is where again like standard distributed systems know-how is very helpful. And all the obvious issues you generally see with the distributed systems are something which you should make sure that you have bases covered. Then something very unique with the AI agents these days is that you expect them to perform like a very long running action, and that may require multiple steps. And when I say multiple, again, let's put some number, right? Like it can be in order of hundreds, not like just tens or twenties, but like hundreds. And every tool call, every shell command it is running, all those things can be a step in its own manner. So as you're going through these 100 plus steps, if the agent ended up committing some mistake at like, let's say, step 20, how do you know that what happens after it, like the remaining 80 steps are not going to be impacted by the error which got introduced at the step 20? So that's like one of the key challenge, and you should always be watching out for this, because if the outcome is not what you expect, you're spending time, money, a lot of debugging cycles, and sometimes you may not even know that what is going wrong, right? Then memory, context, these things are also very critical these days, because again, going back to the same thing, we expect the agents to perform more and more complex tasks. It may have to parse through, crunch through massive amounts of data, right? You can pipe it with like a rag system, but then you can have like just flat files, like PDFs and whatnot. Or it can also require you to just explore like a subset of internet. So when you do all those things at different steps, you need to bookmark or like capture some of the details, so that can be like saved in your memory. In many ways, how do you save it, again goes back to like whether it is file based or like again like a vector db. But how do you do it efficiently and correctly is very important, or else you'll end up with like the wrong answer. Context is essentially like the ram of sorts. I mean, if sorry for the crude analogy here, but as the model is taking action, like performing one step of the reasoning after the next, it would have a very limited in 2026. Again, like you can have like a million token plus context, but then uh, within that window, what has happened is something which is fed into the model for the next turn. So that is helpful because not all the memory would be put into the context by in itself. So how do you manage the context correctly so that your past work, which is right now not part of the sliding window of sort, can still be leveraged and not you don't run in cycles. So that's where the context is important. And blast radius, of course, because now we are talking about like the real damage, actual things can actions are performed, right? So let's focus on like how do you mitigate many of these challenges. So for the non-determinism, again, there's no silver bullet here. It is it's like double-edged sword. What makes the LLMs a lot more powerful at tackling much bigger surface area is what can be the troubling part here. But then there are some knobs in our control. So you can set temperature to 0, which is like, hey, you'd get deterministic responses as much as theoretically possible, which you can reproduce. There can be seeds also when you're training, like all these things you can set. These are like your hyperparameter of sorts. So you can set the configuration to a particular key value pairs, and then you make sure uh, if you run k number of times, how many times you see different behavior, right? Like so you can work around this. You can't like really fix it, but then as you expect model to go from one point to another, you can emit like a typed object, so that way you can enforce the schema between the passes and make sure that nothing funky is happening. But otherwise, pass at k is like a very standard methodology to figure out like, hey, out of 5 or out of 15, like how many times did the agent do the things correctly. Hallucinations are also, as I said, used to be meme like 24, 25, that hey, like model just is making things up. So to give you like a practical example, imagine if it has to, grep through like a directory on your file system, but then the agent simply does not have the permission to do so. But because your prompt said that, hey, don't stop until you have the answer, right? Like sometimes you hear all these new tweaks and quirks from X and wherever, and you feel like, okay, maybe I can change my prompt a little bit, and then I'll have much better experience with the models. But what ends up happening is that because the agent and the subsequent model didn't have access to a corpus of the data, it can just make things up. So how you actually catch this come the eval time is rewarding abstention over confabulation. Like that basically means that uh, create the situation such that underlying corpus is not accessible, and then test what your agent is behaving. The source of truth is that, hey, the model should have rather um, you know raise the hand saying that, hey, I don't have the permission, so I can't tell you one way or the other, versus if model is very confidently making things up. That's when you know that more tweaks are required in your like broader end to end. Adversarial probes and like all these things are like common. Tool calls I already mentioned. A lot of the standard distributed system hacks would be very helpful here. Uh, if imagine like you are expecting the model to even book a flight for you or book a hotel for you. So anything which requires like exchange of money, those are in like your database world, the very critical rights. So you want to make sure that you don't double book, you don't want to get charged twice. Of course, the actual reservation system would also be managing a lot of it, but then from pure tool call perspective, you can have a concept of idempotency, right? Like so you make sure that over retries, it's still using the same idempotency key, and that way you deduplicate before committing any serious action. Next can be retry and exponential backoff. So again, in a normal distributed systems, if one server is talking to another, the second one is slow for whatever reason, the first one should not be constantly bombarding, like polling every few seconds. It should rather wait for one, then two, then four, like power of two. So that's again like exponential backoff, and that's when you retry. Saga style compensation is also interesting. So imagine if you ended up making a reservation, but a wrong one. Like essentially, your model, your agent is actually reserving something, but what it ended up reserving is wrong. Now, of course, there would be a row in a database. If you want to negate what agent just did, if you want to fix this behavior, you won't be simply removing the row from the database, right? And in most cases you won't have access to database, like the backend of all the different systems which you don't own, but you are using here. So in that case, cancellation by in itself should be like a first class citizen, such that your undo, like your fix of what agent messed up, is done cleanly, right? So again, this is like a very subset of tool calls. Most of it, like you most of the times you are going to just be reading more information than what you write, but then the blast radius is much bigger when you write. So that's why this can be helpful. And of course classify as much in detail as possible whenever a tool call fails. Again, many of the times it can be simply an issue of like authentication authorization failure. You can get 429s, like getting throttled all the time. But then in some unique cases, it can be the case that hey, the different steps of the agent actually performed malformed output. So what do you do in that case? That becomes important as well. Error accumulation I briefly touched upon. Like imagine if there are like 100 plus steps and then you commit an issue, like a mistake on 20. How do you know? So that's where checkpointing after every few steps is helpful, such that at any point if you capture that hey, maybe the step 25 failed, but if you're checkpointing at every, let's say, 20 steps, you can safely possibly go back to the state of at the time of step 20, and then resume again from there. So here again, persisting the state correctly, cohesively, such that it is self-sufficient uh, when you want to start from that, like a point in the history, is very much critical, right? Otherwise you can't do this. So roll back again, like if you have the persistent state, you can roll back to the known good checkpoint, and then you don't let the errors accumulate. Otherwise again you'll be wasting a lot of resources. Memory and context also I touched upon earlier, but the fix here would be to look at it from even like a lens, deeply, like a layer deeper. Not all the things are worth saving in memory, and then some of it can be just something which your model has summarized. Now summaries should ideally have like a finite lifetime, after which the underlying base facts can change, so the summary can also change. So how do you make sure that different kinds of data you bucketize? Something can be user preference, something can be like just absolute facts, like what is the capital of France? That is Paris. It's not going to change, hopefully, like as often, like yearly or something. So with those things you can lock it down, and like in your memory. Again, like a very crude example, of course this is something already baked into the base checkpoint of the model, so this you won't have to do. But just match this with something within your org, right? Like something which is known fact, that can be stored in a unique way compared to like a derived summary. And TTLs, again, think of it like the analogy wise, like cache wise. You certainly want many of these data to be accessible in the short run, but like perhaps expire afterwards. Provenance is like one of the key aspects, and sometimes not as thoroughly understood. You would want to understand that any piece of thought, like which you inferred as an agent from the underlying model. You want to know what was the source, at what time did you exactly had this inference, and then if it is not pure black and white, like what is your confidence level. So like those things, if put together, you can save it as like some metadata perhaps for the memory. You can do better, like more efficiently, like what agent needs to do. So imagine if there are like five sources, and you are launching like a team of agents, sub agents, one orchestrator, other like the worker agents, and worker 3 still needs to wait for the answer from worker 4, but it can some lose based on some loose data, it can infer something. So here the confidence level would be, let's say, 40 or 50 percentile. But by the time the worker 4 is done computing, done analyzing the real authoritative source of truth, now for the same underlying question, your inference, this is not the like the not the system based inference, like just infer like figuratively, right? Now your confidence can be like p90. So that's when you may want to get past, like remove the lower confidence, lower p value inference, and then have like the other fact in your memory solidified. So the that's like essentially like for the memory and context, a lot of the things can be common here. And then chunking is also very important. When we have vast amount of data, any sentence or any input to the model, for us it can be like plain English or like whatever language you're using this for with. But then to the model, it is in form of tokens. It is token in, token out. So for even converting the given user prompt into the tokens, you chunk along the way, you tokenize, and that's when you have the input in a format which is more likely to get you the response what you want. Now here it matters what exact data you're working with. If you are building a coding agent, let's say you want to build your own cloud on top of leveraging like open code, for example. So in that case, it's not going to be sufficient if you simply split things by like words by in itself. Like of course the language, any language would have like a finite amount of words or like tokens in that sense. But then perhaps like a smarter way of doing it is to look at the abstract syntax tree, like the AST, and then perform chunking at that level, right? So that again, it very much depends. Not everything what I'm saying can be used as like a laundry list of things to fix, but like depending on your exact use case, these are like some of the unique tips, right? Observability, again, it's like fairly obvious. Log as much things as possible. Like the even like the prompt itself can change as you optimize it. The model name, version, sampling parameters, which exact cloud provider are you using, like all those, which model is using what underlying GPUs, everything. If you have it already logged, that's when you can iterate on it like quickly. And then eval suite, again, it's obviously not just cover like the happy path, but all the other weird cases, edge cases, failure modes. Stale memory is one of my favorite. I mean, because many times we expect like, hey, I gave the correct data, underlying corpus to the agent, but it is giving me like a stale information. Imagine if you are working on like 50 people collaborative project, and there are like status updates, at different weeks, months, and whatnot, right? Imagine if you're now, if your agent is actually looking at 2 months old status update, it is going to output like a very wrong summary, which is not going to reflect the reality and like the hard work all of you have put in. So again, that's like just one of the examples. But otherwise, start with simple things. Are you able to catch the authentication failures as the agent is performing stuff? So even those are like very helpful. And then success rate, failure rates, all these are like again fairly obvious things you should be capturing. And then next section, I would like to focus on like the graders part. So a lot of the challenges and the mitigations we spoke about. um, how do we actually grade? How do we actually evaluate? uh, th- so these are there are like essentially three types, roughly speaking, like the buckets. One is the code based or like deterministic graders. Second can be like your LLM-as-judge model based grader, and the third can be actual human graders. And each three of them have their own strengths and weaknesses. By the end of looking at all these buckets, you would want like a nice cohesive strategy such that you have collective basis covered while spending the least amount of money and most amount of determinism. And again, like all the frontier labs, as much as they are performing all the cutting edge research, they still rely on deterministic graders as much as possible. And for the right reasons, correct. The deterministic graders, code based graders, can be fast. It can be like a regex search for all we know. um, you can iterate on it very quickly because it is cheap. You can reproduce across like different runs. But the things where it would fail is that, let's say, a use case about creative writing. Now your code based grader is obviously not going to be able to capture all the nuances. So that's where you'll have to move on to like the more sophisticated, in a way, type of graders. But otherwise, I would say like the standard 80/20 rule apply with all these things. So consider in this case perhaps like 65-70% of many things which you want to measure can be measured like from pure code based graders itself. Of course, the percentage may change depending on the use case, like the category in which your agent needs to be specializing in. But all the things around tool calls, are you passing the valid parameters, are you emitting like the correct JSON, and for schema, like all those things you can like just validate through the code based graders, right? So again, TLDR, start with code based deterministic graders and see how far it leads you. The next is model based graders. So again, let's just continue from the creative writing example, right? You may want to evaluate the outcome of agent around, hey, are you crisp enough, are you concise enough, are you are you citing the authoritative sources while making any statement, any argument. Like all these things you can do with the help of model based graders. Of course it is going to be non-deterministic, because again, to test an LLM plus the agent harness, so the collective agent, you are testing through another LLM. But in exchange of that, as a trade-off, you get a lot more flexibility. It is scalable not from pure systems perspective, but from use cases and like scenarios perspective, more qualitative. So model based graders can be helpful there. Any free form output, like you can evaluate, you pass it through the LLM as judge. Interesting part also you may have experienced as you uh, play with like many of these tools is that it would spit out like two answers and make you vote like which one is better. That is essentially pairwise comparison, but with human in the loop, because you are evaluating between the two. But the same thing can be done by a model. So the base model plus the agentic capability can spit out two answers, and the LLMS judge is actually going to pick one over the other based on some rubric. And that rubric is the name of the game. Like your model based graders are only as good as the rubric. And think of it as, let's say, four or five unique dimensions across which you want to measure the agentic capabilities. Now what those dimensions can be, that is again like your collective source of truth. So again, like your stakeholders, I don't know, product managers, software engineers, everyone combined should ideally sit together and figure out like what does success look like. How do we know that things are working as we expect? And that is where, from that discussion, you will come out saying that, hey, these are the 4 or 5 dimensions across which we want to evaluate, right? And again, like the standard bell curve, you can apply what does good behavior, bad behavior, and what does something which requires further investigation with that rubric. And that's again, that's where you require the human based graders. So example which I the situation I just spoke about, you all would be operating as like a human based grader, but in like a partial capacity, right? Like collectively you form that rubric, But then the idea here is that this should be the gold standard for how you evaluate your own agent. And I'm very much a fan of using Git where you can, right? So all your graders, all the decision logs should be like version controlled, so that for a particular commit hash, you know that hey, this is the exact criteria which we applied. But here again, end of the day, while this gives you the max flexibility, it is also very expensive and slow. Like how many times can you afford to have like a team of 10 people sit together and like again iterate on the rubric itself, right? But a nice point at which you know that you have like fairly stable understanding is when um, for different situations, different, let's say, tasks, you have vast majority of the human graders aligning like, yeah, I agree with what agent did here. So that's when you know that from this point onwards there would be diminishing returns. But again, something to keep in mind. And if you plot all these strengths and weaknesses in form of like a spider graph, I would expect something like this to show up. But the interesting bit here is something where I would nudge you to visualize. Like if you plot the blue, the green, and the pink spider graphs on top of each other, what you would see is that most of the axes are covered to the max. So for code based graders, the nuance is very minimal, but on human based graders, it is maximum. So all these things superimposed on each other, you would see that all the different dimensions, determinism, debuggability, nuance, flexibility, scalability, everything is covered. But of course, you have to keep in mind like the cost aspects as well. Nothing is, as I mean, of course, if you're using LLM-as-judge, you are incurring cost twice. But then, even with the code-based graders, the underlying trace is coming from GPU utilization, right? You are going to be running the agent, so GPU capacity is going to be required. So you have to be mindful. But on the other end of the tunnel, you have a very nice, sophisticated, AI native, if we call that, experience for your product and feature. And while these are again like the standard conventions which we all have been following, something which I've learned through my experience as well, I provided like some nudges. I want to leave you guys with like practical tips, like where do you go from here, right? So I had a great fortune to collaborate with other researchers and engineers within Meta to work on Gaia 2 benchmark. uh, there, as the name goes, it is two, because the version 1 came in 2023. This just came in like 2026. And what are these exactly? What are you talking about here? So these are about 800 very carefully crafted scenarios. And those scenarios are meant to exist in like a universe. So exactly you, but like with your day to day, that can be like a universe in itself. You may be using Gmail or like other mail application, WhatsApp or other messenger, to communicate with different people. You would have some objectives, some to-do list, right? Like, so all those things encapsulated can be like a universe of its own. And then as I mentioned, of course, some apps. But on top of it, like imagine if you want to rent an apartment, so you would go on Zillow or like homes.com, whatever. Not you want to shop something. So all these are like different applications. But then we essentially have the mock versions of these apps, such that if you want to test your agent against shopping capabilities, you cannot have the agent actually hit the actual real Amazon.com. You would get throttled, you would get blocked even before you get throttled, perhaps. So like what you run as part of like your post training, your reinforcement learning, that can't have an direct call to like the real systems, because you won't be controlling all the variables. Your experiments are not going to be fruitful. So you need to work with like the mock versions of these apps. And then against all these different scenarios, how does your agent behave? These are the five dimensions. So I mentioned that, hey, um, come together with your team, figure out like what dimensions. So these dimensions are more about like, between the 2023 and 2026, what are the real value which we are delivering. But then these various categories is where exactly your agent is going to be evaluated on. And to lead with like a nice example, consider a prompt like, hey, I want to schedule a film production day, and for that particular event, if there are any conflicts, cancel them. Email Ross because he's sort of like the required attendee for the thing. And then of course, if you email, that person can respond to RSVP, yes, no, maybe, right? So if he says no or suggests a different time, then reschedule. Now, this is fairly complex if you think about what you're expecting the agent to do. Scheduling something by in itself, sure, that can be like a write against the calendar app. But then canceling conflicts, that requires them to know, like the agent to know, the sense of time, the temporal awareness is required. Ross, there can be multiple Ross in my phone book. So how do we know exactly which Ross are we supposed to reach out to? And then reschedule if he counters. This is, I feel, like one of the strongest dimension to evaluate against, and that goes into adaptability, right? How many agents you see today in the production which are actually adaptive to the different constraints as they are added, released through their execution. So execution by in itself, of course, as I said, actually performing sequence of task itself. But the search, again, that's standard. But the adaptability, time, and ambiguity, these are like the net new capabilities through Gaia 2 you can evaluate. And then of course, with every benchmark you get like a nice dashboard of like different models, how they tend to perform. So as you can see, search, execution, we are in like 80s, sometimes even high 90s, right? uh, that's because that's where the focus has been in last 2 to 3 years. But then something about ambiguity, adaptability, and most importantly time, that is very complex even to this day for like the most frontier of the models. So if through your benchmark you are seeing that your agent is not performing as well on time, like the temporal awareness, that's good. That's because you can have like much more headroom to go past that. And while these 800 scenarios I mentioned are something codified into the benchmark, this is the main value prop. You can extend this. And for that, Meta has also open sourced this GitHub repo called ARE, Agent Research Environments. So think of your in this DAG of different nodes, what you see. The blue one is like the original user prompt, but all the pink ones are what we call as oracle events. So as the agent performs different actions, you can validate each and every part of it as you go along. So just look it up, like simple Google search should get you there. I can also share the links to the ARE GitHub repo. And I hope you found some value out of the whole talk. And I look forward to seeing, how you benefit from the work which me and my team have been doing. So that's where I would end. Looking forward to connect with folks through the conference and afterwards also. And if there are any questions, you can take that now. Thanks.
Yeah, thank you so much, Rushabh, for such an insightful and practical session. I think we have a couple of minutes so we can take a few questions from the audience. Before that, just a quick reminder for all the attendees that all the sessions are being recorded and will be shared with you via the email. And they will also be available on the TestMu AI's YouTube channel later. Maybe I can pull one or two questions. Okay. What's the most counterintuitive thing Evals taught you about your own agents?
Counterintuitive. So many people are experimenting a lot these days through agents itself. Um, from Eval's perspective, I would say that uh, there are layers to hallucinations also. Like that's one part I would say, that even though it was generally understood that hey, the underlying LLM can hallucinate, there can be like some easy quirks around, like how you like what prompts do you have, system prompt wise, like like your agents.md, what do they have. um, uh, that can be something like a nice low hanging fruit. But otherwise I would say you have to look at all the traces as the agent is executing. uh, to me that was actually counterintuitive to begin with, because with the whole aspect of LLM and AI based tooling, you are approaching more towards automation of underlying workflow. But then the raw traces itself, there is nothing more valuable than that. And the reason for that is, uh, you as the end user, or you as even like the developer of the agent itself, you are still mostly looking at like, hey, what's the final answer? Are there any obvious API failures along the way? But things which fall off silently, that can be very interesting to see from, like, let's say, reasoning perspective. Like, why did the agent take path A when there were B and C also available? And that you can only know when you have all the traces, all the observability, and you have to go through them once manually to even figure out how to make the most of it, like by again having some automation to look at the
Mm.
traces. But like from the get go, you have to look at it manually. There's simply no substitute for that. I would say that was the most counterintuitive part.
Yeah, thank you so much, Rishabh. There are like a lot of questions. Maybe we can share it with you for you to answer for the audience later, and we can
Cool.
share it on our community. So yeah, thank you so much once again for answering the question and for such a valuable session. And to our amazing audience, thank you for joining. And if you haven't already, do share your favorite moment or the key learnings from this session on LinkedIn or X with the hashtag #TestMewConf, so we can pick up the winners and give away the prizes. Thank you again, and stay tuned for the next session.
Thanks, Shazib. Thanks everyone for
Yeah.
making it. Yeah, appreciate it.